Holy crap. Well, here we are at the close of the solar day, week 3 of our second month, February. Wow. Okay, well, so I had kind of predicted that on a clear, sunny day like we've had the last couple of days, the system would probably peak out somewhere between 35 and 37 kilowatt hours. And our baseline over the last couple of days has been 40 kilowatt hours, 40.9 today, 40.5 yesterday. Wow, okay. So we knew this was going to be perhaps the case. Again, we're going to start seeing this ramp up, not linear, but exponentially, because again, the way that the roof is laid out and the fact that the days continue to get longer, as well as the angle of the sun continuing to get higher. And so those two things working in conjunction are really starting to pack on the power coming in. And so right now, we'll pull this up real quick here. We'll pull up, I'm going to take a screenshot here, and the benchmarks, as we look at them at the end of the year, will then allow us to make predictions for various points during the year, where it will allow us then to make our predictions better. This, like a lot of systems, is one of those that as you apply some artificial intelligence and other algorithms to the data that's coming in, what you get on a cloudy day, what you get on a clear day, that kind of a thing, it then allows you to better match those up with weather reports and things like that. Here's a screenshot of a weather report that we have coming up. We'll go into that a little bit again when we get back to the studio and go over that in a little more detail. But wow, so let's head back to the studio. Welcome back. Okay, well, so as you can probably tell by my initial reaction, the system is really starting to get its legs. I suppose I should have expected this, but it was still a bit of a surprise to see it build that fast, that quickly. And so here again, you know, let's go back here, we'll pull this back up. Here again, you see that that sunny day for the end of February. This helps us in establishing our benchmarks for certain points during the year. These are going to be really helpful to us as we do our annual closeout. We'll be able to really precisely kind of note certain points in the year where they relate very reliably to what kind of power we're getting. That's also why we're taking a great amount of care in recording what the weather's doing at that time, and trying to be able to make enough notes about weather on each day, especially here in this shoulder period, that might allow us to differentiate between what we can expect for cloudy days, rainy days, sunny days, that kind of a thing. Obviously, the sunny days are the most important, like what we have here. Really critical. Those are the ones that allow us then to, again, make those benchmarks as to what kind of maximum production we could expect for any given day. So what really makes this interesting and shocking was that only a week ago, about a week ago or so, we were peaking around the 35 kilowatt range. And so what I did was I went and pulled back some historical data for the system to take a look at why that might be, what's going on with the panels. So obviously as we progress towards spring, you're winding up seeing the sun higher and higher in the sky, and that's also making the days last longer. The amount of sunlight that we're getting is getting longer. And so the result of that on the panels is this. So here is a shot from the 18th. All right, now this is the layout of the roof, the physical layout representation of what's on the roof. And here, let's bring this up, pay special attention here to the panels at the top center. The ones that are dark, those are panels that are actually facing north. And again, it was a product of just what had to be done for the roof layout the way it was. And so all of these panels that you can see, these are around 96 watts on the 18th. All right, and so then here, let's take another look at them. This is only 4 days later, and they're at 105 watts each. So greater than about a 10% increase in just a matter of days. And again, that's due to that angle change, right? And so here's a magnified shot of those. You can check out the panels that are in that suboptimal position there. And then here, let's go ahead and take a look at the 9 panels that are in the optimized position. Right? So these are the panels that are southern facing and unobstructed. Right? And so these panels, each of these are producing nearly double what the rest of the panels are producing this time of year. And so if all 35 panels were optimized, then the system could be producing roughly around 9 kilowatts. And this will give you a good idea of what might be possible in a kind of a perfect situation, But while all you guys are fantasizing about the perfect layout where you're in a farm, unobstructed, and you have all these panels south-facing, it's probably the best time to kind of remind you that we all live in a less than perfect world. And I set the panels up the way we have them for a very good reason. And I did that so that it would test the exact thing that I'm showing you now, reality. And the reality is that most of the roofs in our neighborhood have this type of roof, where it's very fractured, it's got a lot of facets to it, and not all of the facets point in the right direction. It's very difficult to get a solid space, so then you kind of do what you need to do. And so sometimes it's remember, that you don't go to war with the army that you want, you go to war with the army that you have. And so that's what we did. But it would be interesting to compare our outputs from the various panels that we have now, and so then what that will allow all of you to do is to maybe kind of judge for yourselves what the benefit is versus the loss if you're looking at these panels. Later on, when we do some further closeouts, as we get further along in the year, we can actually get some more data at what happens with that angle change. What we'll do is I'll go back and we'll revisit some of this data here, and it will allow some of you guys to look at your own proposed systems to say, ooh, okay, well, if I have to put panels on this portion or that portion of my roof, you'll be able to get a rough idea of what your output is going to be at various times of the year, what type of percentage degradation you're going to see. Let me pull this, it's important to, let me pull this shot back up again. So here again, we're seeing the roof that I have. And so what you'll notice here is that for the purpose of the Energy Sovereignty Project, this roof was perfect. And that was why I decided to do that at this home instead of here at the studio. Here at the studio, we have a much more optimized roof as far as that goes. Also, the power usage isn't all that low. But, if I just wanted to show, what a unicorn petting zoo would look like, sure, we could have set that up here. But I think it's really important that we see things in a real world setup. And so on this layout here, you can see we have panels pointed in just about every direction. And so when we do finally analyze this data at the end of the year, it'll give you guys a good idea of what to expect if you have panels facing in these directions. So that might be interesting to see as we move along. But what is clear is that very soon we're going to need to start doing some driving, and so we'll have to figure out what we're going to do with the additional power pretty soon. But so okay, well, let's move on here. We'll pull up the dailies for this week, and then go over some of the projections for the next week as we close out week 3, and maybe spend some time addressing a couple of special items along the way here. In our previous closeout, we ended with the system in an interesting kind of a recovery mode. The system had just finished with a string of bad weather days, and it left the system depleted. We had to switch out of zombie apocalypse mode and set the system on self-power, but self-powered to a 0% reserve. And so now it's really interesting to watch how the system starts to recover day by day out of that situation. So the result was that on the 13th, 14th, and 15th, they took power off the grid, but by the 16th, again, it was starting to supply the home off of stored power. So let's go ahead and go through that period in kind of a fun way by first pulling up the dailies and then laying a graph over it for the month. So here is the February 15th. That's the rainy day that we had at the beginning of last week's update. And the important takeaway on this day is that the system reserve, again, like I said, was set to 0% on the previous day. And I was curious to see if it would make it, and it did, just by the skin of its teeth. And by the end of the total solar day, we're at 21%. And again, it's pretty typical that we lose 20% overnight. And so that was our expectation. And here on the 16th, that's exactly what we got. 1% remaining. And got a decent amount of daily production that day, 39. It was pretty good. And so that left us, with a total solar day of 25%. And here we go, 17th. Again, just about exactly what we would have expected. Started the day at 5%. We ended at 30 with a total production of that day of 28.9 kilowatt hours. Pretty good. And the 18th and the 19th, however, presented us with clear skies and a good opportunity to really kind of bang some power back in here. So here's the 18th. And this was where we charged it at 39.4 kilowatt hours. Total solar day ending at 44%. And then on the 19th, again, pretty good production, 39 kilowatt hours, ending with a total solar day percentage of 55%. So we're slowly kind of creeping up there. And then on the 20th, brings us back to a little bit of overcast weather, but again, still some decent production, 60% at the end of the total solar day, 34.7%. As you can see there, production, and right around 10 kilowatt hours more than we used. But the 21st and 22nd, though, wow. I mean, wow. Percentage ended at 78% after 40.5 kilowatt hours of production. And then here on the 22nd, we have another fantastic day of production, 40.9 kilowatt hours. And so in just under a week, our benchmark went from 35 to 40 kilowatt hours. And this affects everything. It affects our recovery rates, how quickly we can, recover from a cloudy day, that kind of a thing. And really important. So, here, let's take a look at that weather report again. And so now this brings us to kind of a decision point, right? So like we said, those are important to take a look at what data is available to us to then start to make our predictions for what it is we're going to do. So we remember the mistakes of the past, right? So we were sitting at 90% before, and then we're all worried about what the morning was going to bring, and then you wind up taking too much power off of the car. So what do? Do we charge? Do we wait? in a real world, some of the things that we need to kind of take into account in situations like that are things like work. You know, in this case, it's Friday, and so Saturday, you know, we'll be home and we'll have access to the car. The car will be in the garage, and so if we wind up seeing that we're approaching that 100% mark, plug the car in, charge it up, bring some power down a little bit, and then, you know, you got power that you are using rather than just sending it out to the grid. But what if we weren't going to work? You know, what if we didn't have the day off? We were going to work, you know. So those are some of the things that we have to kind of factor in when we're starting to make those decisions. You know, obviously you can leave the system on an automatic mode and have it send power out to the grid, but that's maybe less of an ideal situation. So, yeah. But leave you a little suspense for next week's update to, you know, see how, you know, how we made out with the stormy weather and what our decision was. But we'll end this update here with something a little fun. So, for the purpose of the Energy Sovereignty Project, you know, our goal is to do a real kind of deep dive into these subjects. And so early on, we got the question of, you know, well, do you really need all those batteries? And we heard that quite a bit. And so as we start to progress towards spring, now we'll get a real opportunity to start to answer that question. So let's take a fun look here at this month in just a little bit different way. So here's a graph for February, right? So when we close out the month in February, we'll take another look at both February and January, and we'll look at them with some of the same numbers that I'm about to go through here. And so the first thing that I'd like to have you look at with this graph is, let's start by subtracting our losses. Now, as a general rule, we're losing about 1 kilowatt a day for losses, but to put a more precise figure on that, on the 13th, our lowest day, we showed the production of the system at 4.76 kilowatts, while the Tesla Gateway shows us at 4.7. Not a big difference there. Our highest production day, good day to judge what our percentage is that was on the 22nd. Well, on the 22nd, the production shows 42.439 kilowatt hours, and the Gateway reported 40.9. And so when we crunch all those numbers, it gives us a loss of about 3.7%, 3.76%. Not bad loss, really. That's right in kind of what I was what I was expecting there, in that 3 to 4% range in that first pass. And so take that into account as we look at this graph. So what you see here in red are the actual use numbers for each day. So before, we were limited to having to average that as a single bar going across the month, because that's the feedback that we got from our utility. Now we're able to use the Tesla Gateway to get daily feedback that we're recording. And so those red bars show exactly how much power was used on any given day. So that's very handy. And so now what we'll do is we will bring in the usage, excuse me, what we drew off of the utility, and compare that with what we've got here. And so the gray lines there, that's what we pulled off of the grid. Wow, that's pretty impressive. So out of the total, out of the total 23 days that we have in February so far, the grid has been supplying no power at all for 16 of them. That's pretty good, and that trend still continues right now. I expect that we'll probably finish out the month with the same. I don't think that we'll use any more power off the grid. We might. We'll see what happens with this next week of rainy days. So this brings us to a point where we can better answer that question. Do we really need all these batteries? Well, it's clear when you look at this daily graph here that you wouldn't be able to get nearly as many days in this month if you had smaller, if you had a lower capacity. So next week, when we close out the month, what I'm going to do is I'll revisit both January and February, and I'll do a calculation. And what I'm going to do is I'm going to crunch all of the numbers and look at the usage and supply, both what we got in solar and what we had to draw off of the grid, that kind of a thing, and compare that to what we would have gotten off of a system that had 3 power walls and 4 power walls. All right, so I think that'll be kind of an interesting thing to compare. So with that, thanks for spending your time with us as always, and remember that our content is greatly dependent on the replies that we get to the videos. We derive a great deal of what we show and how we show it from what everybody watching is interested in. And as always, if this is the first video of ours that you've stumbled onto, feel free to like and subscribe if this is the kind of thing that interests you as you follow along this craziness. And again, thanks for joining us. We'll see you next week.